Hello, my name is Sehun Lim, and I'm a second year pre-dental student at Dan국 University School of Dentistry. In this presentation, I'd like to introduce a study titled Effect of Zirconia Surface Treatments on the Shear Bone Strength of Veneering Ceramic. This study was published in the Journal of Prosthetic Dentistry in 2011 by Hongju Kim and colleagues from Jeonnam National University School of Dentistry in South Korea. Zirconia is commonly used as a core material in dental prosthetics because it has excellent aesthetics, strength, and biocompatibility. However, in clinical settings, failures such as chipping or delamination of veneering ceramics often occur. In particular, for zirconia restorations using YTGP, yttria stabilized tetragonal zirconia polycrystal, the failure rate was reported as 13% after 3 years and 15% after 5 years. These failures are mainly due to weak bonding between the zirconia and the veneering ceramic. Many surface treatment methods have been suggested to improve this bond, but so far there is no clear agreement on which method is the most effective. The purpose of this study was to evaluate how different surface treatments affect the shear bone strength between veneering ceramic and zirconia. To do this, the researchers divided the zirconia samples into 4 experimental groups, each receiving a different surface treatment. They then compared the bone strength values among these groups. The null hypothesis was that there would be no significant difference in shear bone strength between the surface treated and untreated groups. A total of 32 YTGP zirconia specimens were prepared and divided into 4 groups. Group C, control group, only ground with a 320 diamond disc. Group A, treated with airborne particle ablation using 110 micrometer alumina. Group L, applied with a ceramic liner. Group AL, both sandblasted and then coated with liner. The veneering ceramic was shaped using a silicone mold into a cylinder, 2.4 mm in diameter and 3 mm in height, and placed on top of the zirconia blocks. You can see this design in figure 1A and 1B. The bonding strength was measured using a universal testing machine where a semicircular blade applied force at the interface, shown in figure 1C. After the test, the fractured specimens were analyzed using field emission scanning electron microscopy, called FESEM, to observe the interface and failure types. For statistical analysis, the researchers used one-way ANOVA and Tukey's post-hoc test to determine if there were significant differences between the groups. Let's look at the result now. First, figure 2 shows a bar graph comparing the average shear bone strength. Group A, sandblasted, has the highest value at 36.63 megapascal. Group C, control group, 32.08 megapascal. Group AL, aberration plus liner group, 30.51 megapascal. Group L, liner only group, has the lowest value at 27.87 megapascal. According to Table 2, Group A had a significantly higher bond strength than Group L and Group AL. There was no significant difference between Group C and L. Moving on to the microscopic analysis, Figure 3 shows SEM images of the interface cross-sections. Group A and Group AL showed roughened surfaces due to sandblasting, which helped with mechanical interlocking. On the other hand, Group L and AL showed voids and no clear liner layer, which may weaken the bond. In Figure 4, you can see the interface at 50,000 times by magnification. Group A displayed fusion of crystal structures and an irregular transition zone, which is good for bonding. Group L showed a smooth and distinct boundary between the zirconia and ceramic, indicating less chemical bonding. Finally, Figure 5 shows low magnification images times by 50 of the fractured surfaces. All specimens broke at the interface, but Group L and AL mostly showed adhesive failure, meaning the bond failed at the interface. Group A showed cohesive failure, which means the ceramic itself cracked, a sign of stronger bonding. So, what do these results mean? The study showed that airborne particle abrasion significantly improved bond strength. This is because sandblasting makes the surface rougher, which helps the veneering ceramic to mechanically lock onto the zirconia. On the other hand, applying a liner didn't help. In fact, it reduced bond strength and increased the risk of interfacial failure, possibly due to trapped voids or poor adhesion. The study also mentioned thermal expansion mismatch. Zirconia has a coefficient of thermal expansion CTE of 10.48 times by 10 to the power of minus 6 per Kelvin, and the veneering ceramic has a CTE of 9.1 times by 10 to the power of minus 6 per Kelvin. This slight difference can create residual compressive stress, which actually helps improve the bond strength. In conclusion, the study found that airborne particle abrasion is the most effective surface treatment for improving the shear bond strength between zirconia and veneering ceramic. Applying a liner not only failed to improve the bond, but also actually increased the chances of failure at the interface. So, in clinical practice, it is better to use mechanical surface treatment, especially airborne particle abrasion, when working with zirconia restorations. Thank you for your attention.